Good morning, it's Miss Hardy recording for Health Science 1. It is Thursday, the 4th of March, and we are well into the digestive system. Mostly everyone completed their assignment yesterday, which was Digestive Functions Part 1, where we went over that basic vocabulary like feces, defecation, uvula, all of those things. So today what we're going to do is start the digestive tract. So if you click on this assignment here, that's what's going to be due today. It is a flow chart that I've made for you. I know it's sideways, I'm sorry. But what you'll do is you'll fill this in with any pertinent information. I'm fixing to go over the really important information. So you can fill this out when we finish. Clicking back into our modules, we're going to use the same PowerPoint from yesterday. So Digestive Functions Part 1 PowerPoint. This will also help you complete Part 2. We're just using slides 16 through 31. So let's get started. Before we rock and roll, does anybody have any questions? Perfect. All right. So we know that this is where the digestive system happens. So I'm going to be able to show you guys this. Our first block is the mouth and the teeth. So we know the mouth is the entrance to the digestive system. Remember, the mouth serves as the entrance. The anus serves as the exit. The mouth is the first step in mechanical digestion. What is mechanical digestion? It's the art of chewing, mastication. Okay, so this is where you can take that vocabulary from yesterday and use it on this sheet that I've given you to help you study. We know that the palate helps separate what? The palate, you know how we have a hard palate and a soft palate. What does it help separate? It helps separate all the cavities above, like the nasal cavity, from our mouth so that the food, when we swallow, doesn't go into our nasal cavities, which could eventually go into our lungs and give us pneumonia or potentially kill us. So that's really, really important. We know the uvula is an important structure in keeping food from going into the nasal cavity as well. So all of those things are things you can include.
Please excuse the announcement. The face-to-face will be held in the data room. The face-to-face will be held in the data room.
So it's really important to put that pertinent information there. You shouldn't use this block to write the notes word for word, because at this point, we've already talked about a lot of these pieces. So this is just the highlights, the important stuff. So after we have food mechanically broken down in our mouth using our teeth, we would move, and we know the tongue is an important part of that. It helps us move food around. It's a muscle. It helps us talk. It helps us chew. It helps us eat. We also know the salivary glands exist there. So if you're having a hard time remembering that, you can include it here: parotid, sublingual, submandibular. We know our teeth are important. We move to the stomach. Excuse me, actually your chart includes the pharynx and the esophagus. So let's talk about those. I know they're not in this PowerPoint, but they are in the PowerPoint that we covered the other day. So the pharynx has 3 sections. What's the first one? Anybody remember? It's up here. It's because it's like when you suck a snot, a loogie from your nose, it can go back from your nose down the nasopharynx, to the oropharynx. So go ahead and write that down if you don't have it. This is a reminder from your slide the other day. The pharynx has 3 pieces. The nasopharynx, where do you think that's near? Your nose. Good job. Then you have your oropharynx. Where do you think that's near? Your mouth, your oral cavity. Then you have your hypopharynx. Hypo means what? Below. So the hypopharynx is the last part of the throat before you get to the esophagus. So you do need to know the 3 parts of the pharynx: nasopharynx, oropharynx, and hypopharynx. And it's one continuous tube, okay? So remember when we talked about vomiting the other day? When you vomit, it's a forceful ejection in the opposite direction that food is supposed to go, right? So that's why sometimes you can vomit out of your nose, or if you were to cough up a drink, you can cough it up your nose, because it is all very connected, okay? Once we leave the pharynx, we go into the esophagus. What do we know about the esophagus? It has peristalsis starts in the esophagus. It moves the food down, okay? Gravity helps move the food down as well. We know that there are 2 sphincters in the esophagus. We remembered that from our last PowerPoint that we did. Does anybody remember what they're called? It's called the upper esophageal sphincter and the lower esophageal sphincter. So look at me, okay? Where do you think the upper one is? Right here. It's where the pharynx meets the esophagus and the food passes through. Okay, so that's the upper esophageal sphincter. Then you have a lower. Where do you think the lower allows the food to go? From the esophagus to the, what's the next step? The esophagus connects our throat to our what? Our stomach. So the lower esophageal sphincter allows food to pass from the esophagus into our stomach. Now, I put a little side note here about the cardiac sphincter. The cardiac sphincter is that sphincter within the stomach that allows food to pass into the body of the stomach where all the gastric juices mix together. So you'll see it right here. So sometimes this can be also be like interchanged with that lower esophageal sphincter, but just know that's how food passes through. Sphincters are a circular, muscular structure that allow, it's like a one-way valve. What does that mean? It is only supposed to go one direction, okay? It is only supposed to go one direction. Let me make sure there's no one else in our waiting room. Hold on one second. There's not. Okay, perfect. So here's a picture of our stomach here, okay? So we know a lot about the stomach so far. We know that the stomach has gastric juices. The stomach mixes and churns. It churns all those gastric juices with the fluid that you drank, with the food, and it creates, what do we call that? What's that funky word? We create chyme, okay? So chyme is created within the stomach. So remember, we have the fundus of the stomach, which is at the top, okay? We have the body of the stomach, and then we have this area where the food is getting ready to exit and go into the next stage of the tract, okay? So let's move through. There is a little note here that the cardiac sphincter is that one-way valve located at the end of the esophagus, which prevents backflow of the stomach content to the esophagus. Now, some people have that. It's called gastrointestinal reflux disease, okay? It's when the gastro and intestines reflux or go back up that valve in a way that they're not supposed to. Stomach acid is very strong. It can cause erosion of the esophagus. It can cause pain. It can feel like a heart attack. So this is something that you would want to get treated, okay? Moving forward, we have the pyloric sphincter. That one's located at the bottom in that pyloric area, okay? The pyloric sphincter is what prevents backflow from the intestines to the stomach. So again, looking at our chart here, you can recognize that wherever a sphincter is, it keeps food from going back in the wrong direction, okay? We know that the stomach turns into the what? After contents leave the stomach, it goes into the small intestines. So the first part of the small intestines is that D word that you see on this slide, the duodenum, okay? So if you don't know that D word, I've given you a space to write it. Duodenum is the first section in the small intestines. Now, I understand that I put small intestines up here under this block, but you do need to know the individual parts of the small intestine. And remember, the small intestine is really, really long. Why do we call it the small intestine though? Because it's not as wide as the large intestine. It's a much narrow, more narrow opening. So moving forward, a little bit more about the stomach. So we're kind of learning parts and pieces as we go. The stomach has what we call rugae, okay? Rugae is the mucus coat lining of the stomach, because if the stomach is so acidic, then how does it not eat itself from the inside out? The rugae help keep us protected from those stomach juices entering the rest of our body. The rugae will stretch and allow the stomach to stretch. And then when your stomach empties, it will come back together. So again, we're think about like a blanket. You can open a blanket all the way up, or you can scrunch it together. So that's what we're doing here, okay? We're scrunching it back together because it's empty. You would open a blanket up to put something in it or cover something up, and then you would close it when it doesn't have anything to do. All right, what questions do you have? There's a little bit more anatomy terms on this screen. So we know our rugae are these folds. We have the fundus at the top. You have your lower esophageal sphincter, which again, we've kind of figured out, it kind of uses interchangeably with cardiac sphincter. This is the cardiac region of the stomach. Don't get it confused with heart, okay? Don't get it confused with heart. We have the body of the stomach. We have the pyloric region of the stomach. This is when food has been churned, and it's fixing to leave. Now, if you eat a piece of pizza, Does the whole piece of pizza pass through your digestive tract at the same time? No. So small amounts of what we call chyme, and that slide is coming up soon. Small amounts of what we call chyme pass through at a time. So we'll pass a little bit. That's why after an hour, you're probably not hungry anymore. You're probably not hungry yet. After 2 hours, you've passed a little bit more of that pizza. You might be a little bit more hungry. You could eat a snack. After 3 to 4 hours, your stomach has emptied because all of that pizza has slowly passed through in those small amounts of mush, okay? So the esophageal muscular coat contracts. So that's what we call that peristalsis, which is like those wave-like motions. So it contracts and slowly, bits by bits, like what you see up here. This might be a small amount of mush, passes through at a time. And again, that peristalsis starts in the esophagus because once we swallow, we don't have control over what's moving through our digestive system. What system of the body has control? I told you yesterday. The nervous system controls it, okay? So for my honors class, that's gonna be really important to do your honors discussion post this week. But the nervous system controls it, so I don't have to think about it. Okay, go another inch down my esophagus. Okay, it does it on its own. So once we get to the small intestine, DJI, okay, or DJ Illy is what some people call it. I just remember DJI, but if you need to remember it as DJ Illy feed, feel free. You know, if you want to make up your own saying, whatever works for you. The duodenum, the jejunum, and the ileum. This is where we switch from digestion to absorption. Please make sure you understand that. Once we get to the small intestine, I told you that the small intestine is full of tiny little what? They're red. The small intestine is full of blood vessels that absorb the nutrients we're pulling out of the food that we eat. So that's where we're getting everything where it needs to go to use it within our body, okay? So our digested food our digestion ends in the stomach, okay? And then we move to the small intestine where things are gonna be absorbed back into the bloodstream and anything that we can't digest. So corn, we talked about that. You've seen corn in your poop before if you eat corn. Corn is indigestible, so it's gonna continue to pass through. Parts of your meals that we don't digest, that we don't use, or that we don't need will pass through as well. So for example, when I was pregnant, I took a pill that the pill would dissolve within my stomach, but the outer lining of the pill didn't dissolve. It was indigestible. So when I pooped, I saw the parts of the pill that didn't digest. So that's how it moves through your system, okay? Once we pass into the large intestine, we're moving on to a different process. So we're gonna come back to that. A couple of things you need to know. These are all considered fairly primary structures of the digestive system, but there are things that happen with those accessory structures within the digestive system, the pancreas, gallbladder, and liver. So we're gonna take a little pause from our actual flow chart and talk about what happens with the pancreas, liver, and gallbladder. You have room on the side or on the back to write this information, okay? So the pancreas has an exocrine function. So look at the first part of exocrine. What do you think this means? Do you think something enters the pancreas or exits the pancreas? Exits, because exocrine means that it secretes something or something exits the pancreas. So the pancreas secretes different digestive enzymes, and enzymes was one of those words we learned yesterday that help break things down, okay? So the pancreas secretes those enzymes to break things down outside of the bloodstream. Now, the pancreas is really cool because it also has an endocrine function. We're going to talk about that later when we talk about the endocrine system. But just know for the digestive system, the pancreas's function is it secretes enzymes that help us break down food. So it's a heavy hitter in the endocrine system, and it's, you know, a bench warmer in the digestive system. So if you were having confusion about how you see things, this is your liver, the big brown organ that you see over there on the model. This is your gallbladder. It's the green organ that secretes bile, and this is your pancreas. Now remember, in a model, if you can see the stomach, you will not be able to see the pancreas because it sits just behind it. So what they've done is given you an outline of where the stomach would be. But this is all connected. Okay? Moving forward to the liver. The liver manufactures bile. The gallbladder is where bile hangs out. Okay? So the liver manufactures bile. It also produces and stores glucose in our body, which we know you've probably heard about with diabetes and things like that, where you have to check your glucose level. In our body, it's actually called glycogen. Okay. The liver is also responsible for detoxifying our body. So the liver is responsible for how we process and metabolize drugs, alcohol, and any other harmful substances. Okay. So let's say you drink a bottle of wine. None of you should be drinking a bottle of wine, but let's say you do. Okay. Or let's say an adult of legal drinking age drinks a bottle of wine. The liver is going to be responsible for, we know that the bottle of wine is going to cause intoxication within this person. Over time, over the next, let's say 10 hours, the liver is going to metabolize or break down the alcohol within our body and get rid of it. So you're not going to stay drunk. You're not going to stay intoxicated, but over time you'll feel less and less because the liver is slowly getting rid of that substance. Now, of course, you can damage the liver. If you do drugs consistently, if you drink on an excess on a consistent basis, or if you ingest any other harmful substance, if you were to drink any sort of poisonous substance or come in contact with it, the liver is responsible for detoxifying. Well, if the liver can't do it, then those substances build up within your body. So that's how we lead to cirrhosis of the liver and things like that. The liver also is responsible for manufacturing blood proteins, and it stores vitamins A, D, and B complex. Those are more of accessory facts for you, so you don't necessarily have to remember those. Sorry, guys, Miss Hardy's getting hot. But it's important information for you. All right, moving on. The gallbladder stores bile, okay? So when you eat fatty foods, fried foods, foods that aren't good for you, foods full of processed sugars and junk, the gallbladder will release bile. Well, sometimes when someone has a diet that is high in those fatty contents, the gallbladder will get inflamed because you're overworking it. And that's when the person has cholecystitis, which means they may have to have their gallbladder removed. Some people are completely healthy and have to have their gallbladder removed. It can be linked to hereditary reasons. Your mom had hers removed, your grandma had hers removed. Okay, now I have hers removed too, okay? This, because of where it's situated and because this can truly cause a life or death situation, if that gallbladder were to get so angry that it bursts, it can release bile into your blood system. Not supposed to be there. So that's what can lead to sepsis and things like that. I have my gallbladder and have had no issues, but I've heard that a gallbladder attack or an instance where the gallbladder gets really, really upset feels like a heart attack. So it's very, very painful. Same thing with appendicitis. Different types of feelings. And we know the appendix is kind of like that, what are you doing here, organ of the digestive system? But the gallbladder obviously serves a function. And if it becomes inflamed or irritated for whatever reason, it can be very painful. So this is the slide yesterday that I was talking to you about with chyme. Chyme is semi-liquid food or semi-digested food as well. So what you see here is an example of the stomach. You have your esophageal sphincter, and then this is the capsule that we talked about where they can like let you swallow it to see what's going on. But once those gastric juices have, let's say you go out and you eat a 5-course dinner, okay, and you're really full, okay, your stomach's going to be full of that food for a while because we can't send it all through to the small intestines at one time. So as the stomach juices and whatever you've drank and whatever you've eaten kind of mix together, it becomes almost like a porridge or like oatmeal in a way, a little bit runnier than oatmeal. That's kind of what chyme is. Okay, chyme is just like if you were to take all your food, put some water in it, put it in a blender and send it to the stomach with some stomach acid, that's what it is. Questions, comments, concerns? Okay. So as we move and talk about the large intestine, I don't know why that's blank. The first part of the large intestine is your cecum. So I have put that here as just your little entryway. The cecum is not a sphincter. It's just the lower portion of the large intestine. When I say lower portion, remember I used a flight of stairs to explain the large intestines. You got to climb the stairs, go all the way to the other end of the floor, and then go down the stairs. That's the large intestines. In the large intestines, we're starting to make what? We're starting to make feces, okay? So what they have to do, and I wish I had a picture of it. Let's see. I don't think I have a good picture in here. Maybe there's one next. Anyway, what it has to do is the food has to go into the large intestine, entering the cecum, move through the large intestine of the ascending colon, so you're climbing the stairs, to the transverse colon where you're walking across the floor of the hotel, to the descending colon where you're going back down the stairs to get where you need to go. Okay, the large intestines are called the large intestines because they are big, they are thick, they are huge in diameter. They're about 2 inches, so they're about this wide, a little bit wider than this, okay? So they're called the large intestines not because they're very long, but because they're wide, they're thick. This is where we're starting to form stool. Moving forward, just again, another little tidbit about the appendix. The appendix is a finger-like projection off of the cecum. We don't know what it does. It has no definitive role. It looks like it may just be a part of the anatomical structure, and you can live without it. If someone were to get appendicitis, which means it becomes inflamed, we can very easily take it out. It's a laparoscopic surgery. You can live without it. There seems to be no complications from it. And again, we don't really know what it does. It just kind of hangs out. This is the cecum, okay? So this is that first part. Now you have another valve in here where the food would kind of enter into the cecum. I'm okay if you don't write that down. And then we go up the stairs, okay? So the ascending colon, just like what you see here. If you don't know the names and you don't know where they are, you need to write that down on your paper. The ascending colon is going to be going up the stairs. You're going to cross over to the other side of the floor and go back down the stairs, okay? That's what you see here, ascending, transverse, descending, okay? Yes, sir. What? That's what the ATD is for. That's what the ATD is for in this block. I need you to know what they are. If you need to write the stairs analogy on your paper, that's cool with me, okay? Up the stairs, across the floor, down the stairs, and now we're getting ready to leave. From the colon, okay, we move into the rectum. The rectum is considered a part of the large intestine. It is your storage facility, okay? So this is what feces looks like in our rectum. It's not a perfect little line. It's not a perfect log, okay? It becomes a log as it comes out of the anus because of the structure of the anus. But poop just hangs out here, okay? As this, I'm sorry guys, I have something in my eye. As this fills up, you will then get the signal that it's time to go to the bathroom. Who does not have that signal? Babies. Who else? If they were to have something happen to them, can you guys think of anybody else who may lose the ability to control bowel movements, lose the ability to move bowel movements out? Huh? So a student said older people. I want you to think back to how we talked about in the skeletal system and the muscular system. There are some people who lose the ability to move their muscles, okay? The anus, the rectum is muscular. Who is someone that may not be able to move their muscles? Who is someone that may have been in a car accident? They may be a paraplegic, okay? So thinking as a healthcare worker, as a paraplegic, if you don't have feeling or sensation or movement below the nipple line, are you going to be able to control your bowel movements? No. Okay, so start thinking as a healthcare worker how this can impact systems, okay? So the rectum is the last kind of holding area in the large intestine, and then we get to the anus. The anus is an external opening. We have sphincters in the anus that we learn to control that allow the passage of feces through the process of defecation from the rectum, the anus, out into the toilet. Remember, I told you that the mouth is the entrance to the digestive tract. In most cases, there are some people who can't eat the way the rest of us eat, so they might have a feeding tube instead. But for all intents and purposes, in a typical situation, the mouth is the entrance and the anus is an exit. Our body is not made for anything to go back up the anus, just like it's not made for anything to go back up the esophagus, okay? So the anus will open, those sphincters will open and allow for passage of the stool to exit our body through a process called what? What's that process of pooping called? Defecation. And guys, we are done. All right, so what we're going to do now in class is I'm going to give you a few minutes to add any extra notes to this. I want you all to make sure you go back to the PowerPoint that we covered on Tuesday, because there are a few little tidbits with the pharynx and things like that that I think you may want to add, because at this point we are going to be closing the book on the anatomy and the structure and the function of the digestive system, and we're going to be moving into the dysfunctions. So you need to make sure you understand what it's supposed to look like, what it's supposed to do, the right tract, the way everything moves in a pathway, so that we can move on to what happens when it goes wrong tomorrow. Does anybody have any questions either in the chat room or in class? Perfect. I will see you all later.